Alex Gross, and this video is presenting a mutation testing tool called the universal mutator. The universal mutator is so called because it is a regular expression-based mutation generation and testing tool that's intent is to make it easy to apply mutation testing to any programming language of interest. So right now you have sort of a huge divide between languages with a complicated, richly developed and supported mutation testing infrastructure like Pip for Java, and languages like C where there are several tools, but they're not really well supported in a lot of cases. In fact, still widely used in a lot of papers and experiments, and even in industrial practices, Jamie Andrews' tool, which doesn't even compile on modern versions of Prolog. So the idea with the universal mutator is let's get mutation testing out there to Rust and to Swift and to Ruby, which probably has some tools, to Python, to all the languages that could use mutation testing. There's been a lot of interest in using mutation testing in actual real-world practice recently, and we want to support that with actual tools. So I'm going to show you command line usage of the universal mutator here. In practice, you know, this system would almost certainly be used inside build scripts and test automation. So it's not really the kind of thing, you know, you probably use all the time at the command line. But this is how you use it, and this is what you'd be scripting. So pip install universal mutator gets you the tool. And let's, since we're talking about how it's a universal mutator, let's mutate a Swift program. So here's a program in Swift. Swift lets you write things in sort of a scripting style. So here we have a program that has a function that gives us the largest and smallest items in an array. And then we have a test, and we've commented the test with do not mutate because we don't want to mutate the test code. We just want to mutate the program. And our test here is not very good. So we have one sorted array, and we check that ls, the large small search, works on that array. It's not a very good test. Let's see how well it stands up to mutation testing. So first of all, one thing that you need to know is that a lot of the work of mutating Swift programs is accomplished actually by very general mutation rules, mutation operations defined as regular expressions. And these apply to pretty much all programming languages. So lots of the things like replace a constant with a different constant, change an arithmetic operator, negate an if or while are handled by these rules. Others, because Swift is a C-like language, are handled by the rules for C-like languages. Finally, there are a few Swift-specific rules shown here. And those are the ones that, you know, give the special flavor of Swift mutation, know things like what its Boolean constants are. But really, much of the work is handled by the universal rules. So even if you don't want to write new rules, you can probably mutate your language using the tool. So let's mutate. So I type mutate large small.swift, and it generates 46 mutants, and then it uses the compiler to check which of them are valid, invalid, that means they don't compile, or redundant, that means they're equivalent to another already produced mutant in object code. So we're letting the optimizing compiler do the work of figuring out which are the really interesting mutants. So we get 20 valid mutants, 20 invalid mutants. Again, we're not even parsing Swift. It's not surprising we produce some invalid code. And 6 redundant mutants. So now, if we want to find out how good that test suite is, we ask the tool to analyze the mutants and to run the test that tells us if the mutant is a problem. We just type Swift large small.swift because remember this is like a script. So here we go. So we see we kill some mutants, we fail to kill some mutants. We get a mutation score of 65%. Now if we add a few more tests, we can get up to a very good mutation score. We also get files, killed.txt, and not killed.txt that tell us what's going on. And that's the universal mutator. It's that easy. Add that kind of code to your build automation, even if you have a multi-language project and you have mutation testing in your language.